Hello everyone, welcome to Unacademy guys, and yes, today we are going to move onwards to our reaction number 35 and 36, that is the Wittig reaction and Wittig related reaction. Okay, so what is that reaction? I'll reveal that very soon, and it's another very important reaction. Okay, so first of all we are going to study what is the Wittig reaction, how many type of elides that you have, and what are the different product that your elides are generating. So it's a very important and a very scoring reaction because almost every exam has Wittig reaction. Okay, so yes, let's talk about it very quickly. So it is the olefination of carbonyls using phosphorus elide. So I think you already know this part very well. The phosphorus elides are sometimes also called alkylidene phosphoranes. Okay, so even if you remember phosphorus elide, that's fine. Typically it gives the Z olefin and is obtained through a four-membered oxaphosphate intermediate, which you sometimes also call the betaine intermediate. Okay, so this is one thing very important that you understand. First thing, that what is a phosphorus elide? Phosphorus elide, or let's say any other elide. Elides are, guys, stable. Elides are stable carbanions. So this is what we have to understand first. Elides are nothing but stable anions. So if this is an elide that I am talking about, the phosphorus elide, then you can also write it like this and it would be correct. So phosphorus elide is just a stabilized carbanion basically. Okay, so you can write this for the phosphorus elides as well as the sulfur elides that we have also used in the Corey-Chaykovsky reaction. Okay, so elides are almost similar. Chalo, so we look at this molecule. Let's say you have a ketone to start with. So you are starting with a ketone and you are making it react with a phosphorus elide like this, and your product is an alkene or an olefin. So depending on the structure of your elide, you are going to get the product. Okay, so we have two types of elide that is going to give you two type of product, and the byproduct is always phosphine oxide. Okay, the oxygen is taken away by the phosphine, and if you want to remember, it's a very simple representation. Just like the ketone like this, just write the phosphine like this. Okay, and then just remove these two and there you get your product. But this is only one preliminary step to understand. It's not so easy to predict the stereo of the product. Okay, so just to understand. All right, so how are phosphorus elides formed? First of all, let's go through that. Formation of phosphorus elide is important for Wittig reaction. It is important for the Apple reaction as well. It is important for the Corey-Fuchs reaction as well. Okay, so see, we are comparing these reactions, and yes, when I am telling you that these are the reactions you need to remember the phosphorus elides for, so you have to write it somewhere so that you remember. Okay, yes. Now, phosphorus elides are very easy to synthesize. You have your alkyl halide. This is your alkyl halide. An alkyl halide on substitution, the phosphorus is going to attack. It could be SN1 or SN2 mechanism. Alright, just that there is a substitution by the phosphine, okay, of the halogen. Now what happens? Now there is a phosphorus having a positive charge, okay, and that is why the alpha hydrogen basically to your carbon becomes very acidic. Why does it become very acidic? Because if it is lost now, if there is a base and base is going to take away this proton, if that happens, that would give a very stabilized carbanion, which we call the elide basically. Okay, yes, this is what you call your elide, and it could be written as a double bond also. It's the same thing. Okay, so first of all we learned how to generate the phosphorus elide. It is going to be the same for the Apple reaction, for the Corey-Fuchs reaction as well. Okay, yes. Now we move onwards very quickly to see the mechanism of Wittig reaction. Super easy mechanism. Let's see what happens. So first of all, guys, it is like a 2+2 cycloaddition like this, and you have to keep the oxygen on the phosphorus side only. This gives you a four-membered oxaphosphate intermediate, which you simply call the betaine intermediate also. Okay, and that further on, let's say, reverse 2 plus 2 cycloaddition, it is going to break the four-membered ring. Right, it is going to break the four-membered ring and it is going to form this alkene. Okay, like this. Okay, so it forms the alkene and your phosphine oxide is eliminated. So this is how the mechanism goes. Alright, so this was our very basic mechanism that we have talked about in the Wittig reaction. But we also have to talk about the stereochemistry. So let's move onwards quickly. That is, you have two types of Elides. And that gives you two different products. So what are the two different products? It would be the Z alkene or the E alkene. Okay, so these are two different products that you might get. So first thing first, if you have, let's say, a unstabilized Elide. What do I mean by that? Unstable Elide. Unstable Elide is basically an unstable carbanion. Yes, which means that if you have an Elide like this, for example, it's this reaction is showing you that you have an Elide like this. Okay, or let's say the proton is removed, you are going to have a negative charge and a positive charge on phosphorus like this. Okay, so if you generate an Elide like this, or if you simply have an Elide in this manner, which actually means you are having a negative charge on carbon and a positive charge on the phenyl group, phosphorus group, sorry. So this makes unstabilized carbanion. Similarly, if what I do is I just remove one hydrogen from this group, okay, and I put a electron withdrawing group at the side, for example the ester, cyanide, sulfonate and so on. So if I put up a electron withdrawing group like this, I know that the carbanion can be now stabilized because it can undergo resonance in this manner. Okay, so that is why it becomes a stable Elide. So the stable Elide is the one which has an electron withdrawing group connected to your Elide carbon. Okay, just that you have to understand. So let's see guys, very quickly look at the first question or the first example. You have alpha beta unsaturated aldehyde, very well, but you know that the Wittig reaction is only concerned about this system, so no touching the double bond. Yes, so which type of Elide do you have over here? This is your Elide carbon. To the Elide carbon, if you have the electron withdrawing group present, then it is going to be, yes, it is going to be the stabilized Elide. It is the stabilized Elide because now it can do resonance. Okay, so how is the resonance going to be? Very simple, not paying much attention to this because we have the reaction to do, so it's just going to be like this. Okay, yes, good enough. So now we move onwards to the unstabilized Elide. This one is your unstabilized Elide, but ठीक है, पहले we'll complete this reaction. Okay, so as I said, the stabilized Elide is going to give you a particular product, and that is the alkene now is going to be the E alkene, or let's say the trans alkene. Okay, so whatever alkene that you have generated, so onto this carbon, onto the aldehyde carbon, we have now generated a double bond in this manner with an electron withdrawing group that specifically gives you major E alkene or major trans alkene. Okay, very well. Now moving onward to the another type of Elide, that is this one. See, you have a base, sodium hydride, and then add this mixture. So you know already that your Elide is going to be like this, CH, and there is a PPH3. How many bonds you have? You have 1, 2, 3 and 4 bonds basically. So the hydride base is going to remove this inner proton. It is going to remove this proton, the bond falls over carbon, and you are going to get CH2 double bond C, single bond PPH3 positive and negative like this. Okay, so this is your new Elide that you get. Now this Elide from this carbon, it is going to attack on the aldehyde. There is going to be the betaine intermediate once again, and it gives you cyclization. So once again, the cyclization happens like this. You had the aldehyde carbon over here, this one. You had the aldehyde carbon right over here, and then you had this carbon right over here, and the one extra carbon is going to help in giving the cyclization. Let me explain that to you very quickly. So for example, your elide actually looks like this. Your elide actually looks like this. Okay, so it is going to give us an intermediate like this, that this is your carbon, oxygen, phosphine, another carbon, and another double bond CH2, and here is NH tosylate group. Very well, so your alkene which has formed is looking more like the allene system, isn't it? It is more like the allene system, and now there is base in the medium. So what we are going to think about is that the negative charge on nitrogen attacks on this carbon and generates a negative charge on the central carbon to get you this product. Okay, so this has been asked in a previous year question as well, if you notice. So after the aqueous workup, it is going to get a hydrogen. Alright, and on the aldehyde carbon you already had a hydrogen, which I had not written. Okay, so this is your product. Also asked in a previous year question, very simple question, nothing else, very simple example. So you just have to take care of these two elides. One of the elide that is unstabilized elide like this, that will give you the Z alkene or the cis alkene. Since it is giving you the cis alkene, you are able to do the cyclization, isn't it? It is going to give you the alkene in this manner. You are able to do the cyclization. Very well. So yes, if you have any other unstabilized elide also, then also you will get the Z alkene. So this was all about the Wittig reaction. That is, when you have a stable elide, you get the E alkene. When you have an unstabilized elide, you get the Z alkene. Let's see two more examples on these. So these examples are from Caruthers. If you want, you can check it out. Very, very important ones. Let's see them quickly. So you have a very big molecule, but it doesn't matter. You know that this is looking at the phosphorus elide. Looking at the phosphorus elide, you will definitely identify that this is a simple Wittig reaction. Simple olefination reaction. So you are only concerned with the carbonyl. That is only aldehyde over here. Nothing else. Okay. Very good. So, right, the aldehyde is going to get attached with this stabilized elide. You see an electron withdrawing group, right? So that is going to give you E alkene. But you see that here you also have two groups. It's not just one group, it is two groups that you have. Still, it is going to give you the E alkene only, and now if you do the numbering, you will know 1, 2, 3 and 4. 1, 2 on this side, and the other side it is 1 and second priority. So now you know that it is the E alkene that we are referring to. Again and again, we are not referring to trans alkene. Why? Because you might have substituents and then you have to give the numbering. Okay, so that is why we are referring E alkene. So stabilized elide having an electron withdrawing group on the elide carbon, that gives you the E alkene. Another one, look over here. So this is your elide carbon in the presence of a base. So this is our sodium hexamethyl diacetyl group. Alright, and yes, it is a base, so it is going to take away a proton from here, and the proton, after being removed, that is going to give you the elide like this. So it is going to be an elide in this manner. Alright, no positive charge because we have written it as a double bond, so let's ignore this. Okay, so this elide is unstabilized. Why? Because it does not have electron withdrawing group, yes, and it would most probably give you the Z alkene, so let's check. Yes, so this is your aldehyde group over here, and the aldehyde is reacting with this elide to give you the Z alkene. So yes, I hope that you would remember this two types of elide in the Wittig reaction that is giving you major two products. Okay, very well. Now guys, let's come on to our 36th reaction, a reaction similar to Wittig reaction, that is the Horner-Wadsworth-Emmons reaction. Okay, so if you want to remember this name, it's completely up to you. If you don't want, then you can simply call it Horner-Wittig reaction. Okay, and it is very popular like that, Wittig-Horner or Horner-Wittig reaction, you can call it like that also. And here this reaction uses the phosphonate ester that we had once generated in the Michaelis-Arbuzov phosphonate synthesis, that I will put up the link of the video. Okay, and I hope that you remember that reaction. I told you that we will be using the phosphonates later. Yes, so this is where we use the phosphonates. So olefin formation from the aldehydes and phosphonates is giving you a alkene, similar alkene, but it is a bit more selective. And what is the what is the important thing about this reaction? The aqueous workup that we do after the reaction, it is more advantageous than the corresponding Wittig reaction, because the phosphonate byproduct can be washed away with water because it is water soluble. Typically it gives the trans alkene rather than the cis olefin. Okay, so typically I am saying once again, because there are some reactions, see, there are always going to be reactions that give you the exception. So there might be some reactions which give you exception in this phosphonate ester also. Okay, but typically, or let's say generally, it gives you the trans alkene rather than the cis alkene. Okay, so we are going to talk about that particular aspect of this reaction. Yes, so what is happening, guys? Let's see. First of all, Horner-Wadsworth-Emmons reaction or Horner-Wittig reaction. What are we doing? We are taking the phosphonate ester. You can just directly go back to the Arbuzov reaction and then come back. So the phosphonate ester still has two alpha protons, isn't it? It has a base. What is the base going to do? Remove one of this proton, and that gives you something very similar to that of your Elide. Okay, so phosphorus has a positive charge already because it is tetra. They go making 4 bonds, 1 2 3 and 1 2 3 4 5 bonds actually. So already there is a deficiency, or let's say positive charge on phosphorus. So that makes this proton, the alpha proton, very acidic. Very acidic protons lost in the presence of a base, that gives you an enolate. Now the enolate further attacks on the carbonyl carbon, removes the oxygen. Now what happens is, after that you are going to get something like this. Yes, you get a new carbon carbon bond. There is still O minus from here. It is sorry, it is looking more like the aldol reaction, isn't it? Because you get the enolate, and you attack on the other carbonyl. So this is looking less of a Wittig reaction and more of a aldol reaction, but it is a Wittig reaction. Okay, so because it is giving you the trans alkene or it is giving you the E alkene. Alright, so it is a Wittig reaction only, but let's see how is that so. So ये जो O minus है, this O minus, it is going to attack on the phosphorus to give you once again the betaine intermediate. Let's see. So what happens is, guys, just focus first thing that I had just written it in a manner so that we see where is the R, where is the ester product, what is the relative stereochemistry. I have just written it in this manner. If you want, you can write it simply also, that this is O minus. When it attacks over the phosphorus, it is going to form a 4-membered intermediate. See, 1, 2, 3 and 4. So it can also form the 4-member intermediate that we have always been doing in the Wittig reaction, like this, guys. So it is still our Wittig reaction only. Yes, and after that by the elimination of the phosphonate ester group, we get our olefin like this. Now, but what is the stereochemistry? What is the stereochemistry of this formed product. That for that we have to see some intermediates. Okay, so this is your Horner-Wadsworth-Emmons reaction, and let's see what is happening. So when you have the kinetic adduct, what is the kinetic adduct? Kinetic adduct is one which is basically less stable, but it is formed very quickly. Okay, so kinetic adduct is when you are having the erythro, or let's say both of these groups on the same side. Erythro matlab on the same side. Okay, so if you are getting both of the R group and the ester group on the same side, and then you do the elimination like this, okay, then you get the Z alkene. Also, when you get the thermodynamic adduct, which is actually more stable. Why is it more stable? Because the R and the ester group are on the opposite side, so it is energetically more stable. So now if you form the betaine intermediate, very similar to betaine intermediate like this, and then you do the elimination, you get the E alkene. So the Horner-Wittig reaction is carried out in the presence of higher temperature, so that we get the thermodynamic adduct and the 3O product and majorly the E alkene. So what you have to remember from this, it is not a very difficult reaction. You just have to remember that when you are using the phosphonate ester, and then a simple aldehyde, okay, you are majorly getting the trans or the E alkene. This is what you have to remember. Okay, alright, even if you don't remember all of the mechanism, just remember this part. It would be very helpful for answering. So let's once see what do we have, guys. Let's see an example, isn't it? We are going to see more examples and might be a previous year question as well. So here you are, you have the phosphonate ester, you have a hydride base. Okay, so the hydride base, you know what is it going to do? Remove one of the hydrogens, one of the protons on the acidic, right, acidic proton basically, and then it gives you enolate intermediate. And you have seen the mechanism just now, so if you don't want to write the mechanism, that's fine. Here is your aldehyde. Aldehyde is going to be attacked. Aldehyde. So yes, no reaction taking place in this part because it is already alkene. Yes, and aldehyde has to be converted into alkene like this. Okay, now the O minus is going to form a bond with phosphorus. It is, guys, going to form the thermodynamic adduct. It usually forms the thermodynamic adduct, and hence it gives you the E alkene. Okay, so this is your Wittig-Horner reaction, very important. Alright, and yes, so I think that you will be able to do this example by yourself. Very simple. Once again, you have the aldehyde, you have the phosphonate ester reacting from this carbon, and definitely you are going to form an alkene by the removal of this phosphonate group. Definitely this part stays with the system, right? This part is going to, this electron withdrawing group, it is going to stay with the alkene. Now tell me this one thing, without the use of this ester group, are you still getting the same E alkene? Not at all, guys, because if we don't have the ester group, then how are we going to form the enolate, isn't it? If we don't have the ester group, we won't be able to form the enolate, which is required in this reaction. It is a little bit of a different reaction or from normal simple Elides. So you require the electron withdrawing group, which definitely forms a stable Elide, or let's say a stable carbanion, and that further gives you the product. Okay, so in this case we are not first forming the Elide, we are first forming the enolate, which attacks on the carbon. Definitely it gives you the betaine intermediate, and hence you get the alkene or four-membered oxaphosphetane ring. Alright, so hence you have the E alkene. Once again, very important reaction, guys. So yes, so we are going to see a question from June 2016 paper, CSIR NET exam. Alright, very simple question it is. Actually, when you have studied so much, it would be very simple to you. Intermediate A and the major product B in the following reaction sequence are. So yes, you have an epoxide. See, it's even if you want to write it in the chair form, or if you don't, it's perfectly fine, because you know that an epoxide forms a cis junction. So basically an epoxide is going to be like this. Okay, and ultimately your elide, you also have an elide, guys, which still has a negative charge stabilized by lithium, which means that you have a double carbon anion over here. Yes, that is correct. So first of all, it is going to attack from the opposite side and open up the epoxide. So guys, definitely you are having the epoxide opening like this. Alright, this is correct. And all of these intermediates which are having both of them on the same side, completely absurd. Completely absurd, because the first reaction is just the epoxide opening from the opposite side, SN2 reaction. Yes, so O minus, lithium positive, and then what do you have? Is it a stable elide or a unstable? Or let's say this one, yes. You just have a aldehyde over here, but this is a unstable elide because you don't have electron withdrawing group. Unstable elide gives you what? Does it give you a trans alkene or it gives you a cis alkene? So this question I want you all to answer in the comment section, that it is going to be the trans alkene or the cis alkene. You have to answer in the comment section, and then I'll check that your answer is correct or wrong. So yes, your answer is 1 or 3. You will be commenting. Okay, and I have given you all the hints. Unstable elide. Let's see who has watched this video till the end. Okay, so 1 or 3, which is your correct answer? Alright guys, so yes, I end up the video over here only, and I expect more answers from you, what you think is the correct one, because this is a previous year question, so you have to solve it. Half I have done already, half you have to do. Okay, and yes, more answers in the comment section. Also look in the description for the important links. Okay, and I will paste the link of Arbuzov reaction in the video itself. And guys, also I have forgotten to tell you about this mock analysis, the T10 mock series that we were having. What is the T10 mock series? It is basically one single test having 10 important questions. 10 important questions. So till now we have had very many exams, very many simple tests on Unacademy. Now these tests are basically to improve your confidence in solving questions, only 10 questions at one time. You also have complete mock test. Complete mock test is also there, but the T10 series was to improve your confidence bit by bit. Okay, so if you haven't already given the mock test live देने से क्या होता है, you get your rank. Okay, but if you have not given the mock test live, you can give it any time. Okay, it's already available, but you just won't get the rank. So if you give any test live, you will get your rank out of all of the students. So yes guys, a lot of information today, and I will see you very very soon. Do follow me over Unacademy for regular updates. You have definitely got to have the regular updates. Also join the Telegram group. I will share the link below, and if you are interested in joining me on Unacademy Plus, where I teach full time for the CSIR NET Chemical Sciences, you can use the code Unacademy. You can use the code Jagriti S, alright, to get a 10% discount. So yes, this is my referral code. For further information, you can message me on Telegram. Have a nice day everyone, and yes, don't forget to give the answer in the comment section. Alright, bye, see you very very soon.